means the levels of the data. Means in the classification, either you take it CART or IDT, whatever the algorithm you are considering. There you have already one training data set where the data, well-leveled data is there. But in this case of unsupervised learning, you don't have such information about the data. Okay, so supervised learning, when you have information about the data beforehand, and unsupervised learning means what? You don't have information about the data beforehand. Now, clustering is such unsupervised learning technique. What actually we do in clustering, we try to divide the population or data points into a number of groups such that data points in the same groups will show similar properties, and they are showing some, what I can say, that they will be sharing some kind of property which is uh, more and more relevant inside one particular group. But if we consider two groups, then data points belonging to group 1 will be different from that data points belonging to group 2. So what I mean to say that when we divide the data set into different groups, we try to find out some homogeneity criteria, right? And that criteria either maybe your distance or some particular features like color, intensity, and that may be different means as different from different spec or from different needs also, because in our image segmentation we take color as such homogeneity criteria, and in case of your common machine learning tasks you take distance as your homogeneity criteria, right? So that's it. The definition is what? We try to divide the whole data set into a different number of groups. Now, while doing so, we need to satisfy two properties. The first one is high intercluster property, and the second one is low intercluster property. I just told you that while we are dividing the data set into, say, two groups, then data points belonging to group 1, but they will show high similarity among themselves. Okay, means say this is one group and this is another group. This is group 1, this is group 2. So whatever the points belonging here, they will be similar, but suppose these points belonging to group 2, they'll be different from those belonging to group 1. So what just first one, I have said that the data points belonging to the same group are showing high similar property. That is technically known as what? High intercluster property. Okay, so high intercluster property means what? Data points belonging to the same group should show high similarity. But low intercluster property means what? These two groups, the points belonging to these two should be different from each other. There should be very low interaction among themselves, right? And that is technically known as intercluster property, right? So intercluster property should be low and intra-cluster property should be high. So from this diagram, it's just a example. You can see that these are our initial data points. We have formed 3 clusters out of it. Similarly, it is not the case that you will always get some spherical type of cluster. The shape may be different. Our motive is to just accumulate those data points which are similar in one cluster. That is our motive. The shape may be different, right? Now, from this diagram, if you look carefully, you may notice something that is very interesting. And what is that? That is also a very important fact with respect to your PhD research. You see that this, say this is, I'm naming it 1, this is, I'm naming it 2, right? So there are different data points belonging to one, and similarly for two also. But few some points you'll find, say this one, this one, this one, this one, similarly this one. They are not belonging to any one of such cluster. Okay, so in our machine learning, we term them as outlier. Okay, we term this as outlier. So one important reason why we should go for clustering is that we need to detect this cluster. Okay, we need to detect these outliers, because after doing the clustering, we have found the outliers separated from these groups. They are not belonging to this group. So this means that they are not sharing some properties which can be considered important for our current tasks. So they are the outliers. So with the help of clustering, we can detect the outliers, and we can detect and remove the outliers as far as it is concerned. Now, I already told you that why we need to go for the clustering. And let's again go to the theoretical part. See, clustering is very much important as it determines the intrinsic grouping among the unlabeled data present. So whenever some unlabeled data is there, obviously we go for what? Some unsupervised learning. And there is no such criteria that with the help of which you can consider that one is a good clustering, because they're very different. This is a kind of subjective matter. In our research, in our PhD research, you already, I think, gone through some works, and you have found that there are two of them. One is subjective, another is objective. In one case, we believe, or we do means classify on the basis of individual observation, and while other case we actually try to depend on some mathematical formulas. Here also there is no such criteria that with the help of which you can term that this is a good clustering. No, it's actually based on your current need. Okay, so if it is satisfying the need, yeah, I got that these are the groups and these are the points that they are belonging here that I need to find out. So that's okay. Your work is done, right? But yeah, in case of research, you need to go for some objective evaluation also. That of course you will do it when you study your current need, right? Now, we have different methods under clustering, or you can say that this is a kind of taxonomy under clustering. The first one is density-based method. I know that you have probably heard about what? Population density. Okay, we divide, what I can say that on the basis of population, also we divide our districts. Maybe not so good, but what happens? Suppose that the area-wise, suppose Karbi Anglong is very means big districts, but here the population density is very less in comparison to other districts, like you can consider Nagaon, or you can consider Dhubri. Okay, why I'm mentioning this? Because this is a very practical aspect. We use density-based clustering for this type of means data, or census data. We can call it as census data. So density-based clustering means we try to group the data on the basis of what? Density. Density means where density is high, we can consider them as one separate cluster. And based on that, one famous algorithm is there, that is DB scan. Okay, DB scan stands for density-based spatial clustering of applications with noise. Similarly, other like optic is also there, but I would like to recommend that this DB scan, as a PhD research scholar, you should not skip. Okay, at least go through the steps involved here. Okay, although this is not a part of your syllabus, but you can still go for it. It might be interesting for you. Then we have a very important one that is known as hierarchical based method. So in hierarchical based method, we follow what three type of structure. Three type of data structure you already know. Okay, some roots and some child nodes are there, and those nodes which cannot produce child, they are known as leaf nodes. So that is the basic of tree data structure, right? Now here we use this type of hierarchy based clustering approach, and based on that strategy we are following, there may be two of them. One is known as agglomerative, another is known as divisive. Just a minute. Oh, my class lo আছে এতিয়া. Hello?
Industry training link to পটককে WhatsApp দিব পাৰিবা নি?
কিহৰ?
Industry training link to?
ইণ্ডাষ্ট্ৰি ট্ৰেইনিঙৰ লিংকটোতো হেৰিয়ৰ ওচৰতহে আছে, আপোনাৰ চাহাচাৰৰ ওচৰতহে আছে।
দিব পৰা নাই। Actually industry training link to মানে এই যে ষ্টুডেণ্টক যে ফৰ্ম ফিল আপ কৰিব দিয়া আছে এইটো।
আচ্ছা আচ্ছা, মই চাই দি আছো ৰ'ব, মই এই হেৰি এটা মাজতে আছো। দি আছো।
তুমি দিয়া বুলি কৈছে সেইকাৰণে।
ওকে ওকে ওকে, দি আছো ৰ'ব দেই। Sorry for the interrupt. What I have said that there are two approaches. One is agglomerative, another is divisive. My voice is audible to you, right? You can hear my voice?
Yes, yes,
Okay.
sir.
So how they are classified? One is bottom-up approach and another is top-down. Just let me tell you how we are doing this actually. First of all, in one cases, what happened? We have different data. Now, we consider each of them as one separate cluster. Got it? What I have said? We have different data points. We are considering each of them as one separate cluster or one separate group. Now, this is stage one. This is a bottom up, right? We are moving from the bottom. Now, based on that homogeneity criteria, few clusters will be merged to one. Okay, got it? So few clusters being merged to one. So what happens in the second steps? The number of clusters reduces. Similarly, they will be merged. They will be merged till when they are satisfying this criteria. But when the stopping criteria meets, stopping criteria means we cannot merge it anymore because the belongingness of the data points to those clusters reach to the threshold level. Now they cannot move from one cluster to another. Okay, then we need to stop. And this type of approach is known as agglomerative clustering. And this is a kind of bottom-up approach. Okay, now the opposite case is for divisive approach, and that is a kind of top-down approach. Here, what we do, we consider one single cluster for all the data points. And similarly, based on the homogeneity criteria, we try to divide it into more number of clusters at every step. Like that. So what happens? The points move from each one cluster to another, and we do it till we reach the peak level or threshold is met. At one point, what would happen? We cannot divide it anymore. So this type of clustering where we are actually following top-down approach, this is known as divisive clustering. Now, as a PhD scholar, what you have to do, you have to go through some basic algorithms like, CURE. CURE is for clustering using representatives. BRICS means balanced iterative reducing clustering and using hierarchies. So at least go through them. I'm not saying that you need to work on all this algorithm. No, you just go through them. Whenever you find that this particular clustering is for my use, you just stop there and start working on there. Then the next one is partitioning method. And this is very, very important. Even I work a lot of approaches, work on a lot of approaches where I have actually referred this type of clustering. Where this type of partitioning methods means what? we have been actually given some value like k. K is what? The number of clusters, so that we try to cluster or try to divide the whole data set fix into this k number of clusters. And one such important algorithms is k-means clustering algorithm. Then Clarence and k-means clustering algorithm. Okay, we cannot deny its popularity because everywhere you will find that this algorithm is how intensively used, right? For any kind of task, you can see that this algorithm is being used. Even some books, particularly on k-means algorithm, like k-means 50 years beyond, this type of books you will find it. Okay, if you want to know more on k-means algorithm, I can fix a separate lecture on that, or I'll share one such practical lecture with you. Okay. From my personal experience on k-means algorithm, I try to improve its performance. So 2 works of mine being devoted to this k-means algorithm. Very interesting one. Then we have grid-based methods. Grid-based method means you already know what is grid. This type of structures, they are known as grids. So we divide the whole data set, or you can say that we place the whole data set in a form of this type of grid-like structure, and you can apply any type of clustering algorithm to each particular grid. There is no such constraint that you cannot move for this. You can apply any type of clustering to this type of grid. So as you are going to apply some clustering algorithm based on some suitability conditions. So this algorithm found to be very fast and independent of the number of data objects. Okay, such algorithms like Sting, Click, they fall under this type of grid-based method. Then that's it actually. This much you have to know about the taxonomy of clustering methods. So today, what I have discussed, briefly reviewing what I have actually explained, is about clustering. First, I told you that this is a kind of unsupervised learning technique, and then why we need to perform clustering, outliers, and the different types of clustering. Actually, we go through the taxonomy of the clustering methods. As per assignment, very soon I will share you a link with you. You need to go through it, and you need to perform the practical assigned there. Okay, you don't need to worry. The instructions for doing the same and its demo is already there. The same thing you need to do with your own. Suppose if you are using this Python, whatever the ID. Suppose Prabhat is using some another one, and you are using suppose Spider, whatever. It doesn't matter. But I need the screenshot of the results of the experiments. So you will do that. And one more question that I want to like to ask that you need to answer. That question is that if the noise level of data is very high, please listen very carefully. You need to answer to comment. If the noise level of data is very high, then which type of clustering method you go for applying to this type of data set for performing the clustering tasks. So by 120, you will answer this. Thank you. That's all for today.